Hey guys, in this video the brilliant Mr. B is going to be taking you through looking at congruent shapes. Now there are lots of tricky things to do with this subject, not least the pronunciation of congruence. Anyway, in this video Mr. B is going to be taking you through 15 different examples at 3 different levels, and you can choose to jump into this video wherever you feel most comfortable. Check the pinned comment and the description for timestamps, and then you can jump between the levels. And you might want to start off with medium questions, see if you think that they're okay or not, and then move forward to the hard ones or back to the easy ones. It's completely up to you. No one's watching you, no one is judging you on this. If you want a load more questions to go with this to supplement your revision, then they're all waiting for you over my website.
We're going to have a look at congruent shapes. And by a congruent shape, what we mean by that word is that something is the same shape, but it's also the same size. Now, all 10 shapes on the page at the moment are all triangles. That doesn't mean that they're all congruent because they have the same shape, they're all triangles. By same shape, we're talking about the same angles and the same sides. So same shape really is talking about the angles. Do they have the same angles? And the same size is talking about the side lengths. Do they all have the same side lengths? Now, with all these questions, we have information missing on the diagrams. None of the diagrams have got all 3 sides and all 3 angles. So how can we tell if they're congruent? Well, you don't need a full set of information. You can decide if something's congruent with only 3 pieces of information. And we've got some codes to describe them. So we have S, 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 A, S, A, S, A, S, and H, L. So what do these mean? So it's referring to sides and angles. So with SSS, what that means is you have a triangle, so I'll sketch a little triangle next to it, and you have the value of all 3 sides, A, B, and C. And if you know that all 3 sides are the same size, then the angles must also be the same size. So you can prove that they're the same triangle without looking at the angles. With SAS, what that means is you have a side, an angle, and another side. So if you have 2 sides, A and B, and you have an angle, use a capital letter for that, then if those 3 measurements are all the same, then the rest of the triangle must also be the same. And you can prove that they're congruent. ASA stands for angle, side, angle. So you know what an angle is, and a side and another angle. So we label this, we could have angles A and B, and then we could have a side length C. And if those 3 measurements are all the same, then we can prove that 2 triangles are congruent. Then we have AAS, so S stands for the side, but it's angle, angle, side. So we have an angle, we have another angle, and then we have a side attached to it. So we could label these angle A, angle B, and side. Call this little a because you tend to give opposite sides and angles the same letter, capital for an angle and lowercase for a length. Finally, we have HL, and what that stands for is a hypotenuse and a length. Now, if you have a hypotenuse and a leg off the hypotenuse, it's only hypotenuse if it's opposite a right angle. So effectively, we do have the value of an angle and it's 90 degrees. We don't have any other angles, but we do have 2 sides. We do have a side length B, and the hypotenuse just stands for the side opposite the right angle. So it's very similar to saying that you've got 2 sides and an angle, but they're in a different order, and that's allowed because of the hypotenuse and the right angle. There's no other way that they can be organised to give you 2 separate triangles. They'd have to be the same triangle if those 3 pieces of information are the same. So let's have a look at question 1. So we have a side, 15. We have an angle, 40 degrees, and we have a side, 11. So far, just reading out what we've done in order there, we have a side, an angle, and a side. So it looks like we can use the SAS proof. But let's check the second triangle. It looks different, it's rotated around. Is it the same triangle? So we have a side, 15, we have an angle, 40 degrees, and we have a side, 11. So I've read out the same numbers in the same order. So these 2 triangles are congruent. They both have the same side connected to an angle connected to another side. Interesting, looking at them, it seems like the second triangle has been flipped over it's been rotated. Spin the second triangle around and get the first triangle. You'd have to flip it upside down. And that's something that's allowed in congruent triangles. Moving on to question 2. So looking at our first triangle, I'm going to pick a starting point. Let's start with the 70. We have an angle, 70 degrees. We have a side, 18, and we have an angle 65 degrees. So I read out an angle, a side, and an angle. It looks like it might be the ASA proof, but we need to check the second triangle to make sure that's true. So I started off with 70, let's do that again. So we have a 70-degree angle, we have a length of 18, but then when we have our angle of 65, it's actually right down here at the bottom. Now you can see in the first triangle, the 18 length connects the two angles. But in the second triangle, 18 length does not connect the two triangles, and one of the angles is off on itself. What this means is that these two triangles are not congruent, or at least we can't prove they're congruent. It may very well be that in between 70 and 65, that is also a length of 18, and maybe this could work out to be congruent. But given the information we have, we cannot say that these are congruent, so we have no proof for that. Moving on to question 3. Again, choose a starting point. Doesn't matter where you start. Try not to start in the middle. Try and start off at the edge. So let's start off with a 6. So we have a length of 6, we have a length of 4, and then we have a right angle. This looks like it might be the HL proof. We have a hypotenuse, 6. We have a leg of the hypotenuse, the 4, and we have a right angle. The right angle and the hypotenuse are opposite each other. So it looks like it might be a HL, but we need to check because like with the last question, it might not actually turn out that they both have the same organization of these. So we started with 6. So we had a length of 6, a length of 4, and then we have a right angle. And actually, they are all connected in the same order. So we can say that these are congruent. So we can say we've got the hypotenuse, and we've got a leg. Moving on to question 4. So we have a length of 12, we have a length of 19, and we have a length of 14. So we have 3 sides that are all the same. We have no angles. It looks like it might be an SSS proof, side, side, side. Let's just check that the second triangle has the same measurements. So we have 12, we have 19. It's coming off the opposite side. That's fine. And then we have the 14. So we were able to go around the 3 sides of the triangle, going 12, 19, 14 in the same order. But again, this is just one where it's becoming flipped upside down. So it does appear that the 19 and the 14 are connected to different sides of the 12, but that's allowed. So these two triangles are congruent. It's side, side, side. Now let's look at the last question. So we have a length of 8, a length of 7, a length of 4. So I said 8, 7, 4. Let's see if we can do that with the next triangle. We've got 8, 7, and 4. So again, we have 3 sides that are the same measurements. We can join them all up in the same order. We can say this is side, side, side. Those two triangles are congruent. Moving on to the medium questions. Now we just have more triangles to compare, but we're going to follow the same method. So looking at the first triangle, we have 56 degrees. It has a 15 length coming off that, and it joins on to a 32-degree angle. So it looks like we've got an angle, a side, and an angle. If you do forget the different proofs you can use, just read out what you've got in order. We've got an angle, a side, and an angle. That's ASA. But does the second triangle follow that pattern? So we started off with the 56 degrees. So let's start off with that again. 56 degrees. It has a 15 degree coming off it. Now I've got a choice here to go off 30 or the 15. And I'm highlighting the 15 because in the first triangle, we highlighted 15 there. So just doing the same thing. And then I highlighted the 32 degrees. Now you can see in the second triangle, these are not joined up. And this isn't going to be congruent with anything. It doesn't follow any of the rules. We've got an angle, a side, and then nothing joined onto it. And then we've got another random angle. So it looks like this middle triangle is not going to be congruent. But we do have another one to check. So let's have a look at the third one. So again, same order, start with the 56, then move on to the 15, and then the 32. And you can see now those are joined up in the same order that they're joined up in the first triangle. So an angle, a side, and an angle joined up. And they've all got the same values. So we can say for this one, that first and the third triangles are ASA, angle, side, angle. What I will do here as well is I need to make sure that we know this middle one is not acceptable. So I'm just going to put a cross on the middle one and a tick on the first and the third. So it's clear which triangles I'm saying are congruent. Moving on to question 2, we need to find the right place to start. So I'm not going to start right in the middle with the 41 degrees. I'm going to try and start over towards the edge so I can chain together the 3 different facts. I'm going to start at the end of the 21 measurement. So we have a line with 21 on it. Then we have the 41 degrees, and then we have a line with 38 on it. So it looks like we've got a side, an angle, and a side. Let's check if that's true for the other triangles. So we're starting off again with the 21, moving towards the angle. The angle is the same measurement, 41 degrees, but then the 38 doesn't join on to the angle. Instead, the 38 joins on to the other side. So that triangle is not going to be congruent with the first triangle. And since side-side angle isn't a thing that we can use in proof, I'm going to cross this one out. It's not congruent to anything. Now let's have a look at the third one. So again, I'm going to start off with the 21 measurement, which goes to the angle, 41, which goes to the side, 38. So this time, it looks like it does join the same order. We have a side, an angle, and a side. So write down how we're proving it, side, angle, side. Let's indicate which triangles are congruent. It's the first one and the third one. For question 3, again, try and start over at the edge. Let's start off with the 29, which joins on to 14, and a right angle. So the green highlighted line must be the hypotenuse. It's opposite the right angle, and we have a leg off that, the 14. So it might be HL, this one. Let's have a look at the second one. So let's start off with the hypotenuse. Now, and I highlight the hypotenuse here, it's opposite the right angle. It doesn't have any labels, and 29 is one of the other labeled sides. So it looks like this one is not going to be congruent to the first triangle. Now let's just check the hypotenuse of the third one. This one is 29, because it might have been possible, perhaps the first one was the one that wasn't congruent, and the second and third might be. So I'm just checking the hypotenuse of all 3 first. So it's definitely going to be the first and the third congruent, if anything. But let's just check the rest of it. So after 29, I have the 14, and then we have the right angle. So that checks out. Looks like it works. So let's write in HL. We have the hypotenuse and a leg or a length coming off that. And again, the congruent ones are the first one and the third one. Moving on to question 4. Let's start off with the 13, which joins on to an 8 and 11. So that would be side, side, side. So let's check the other ones. What 13, 8, then 11. Can we do that? So we're going to have 13. 8 does join on the top, and then we have 11 on the side. So the first 2 are congruent, give them a tick, and it's side, side, side. All that's left now is to check if the third one is congruent. So starting off with the 13, and the third side on this isn't labelled with anything. We have the 11 and the 8. We don't have the 13. Now again, it's entirely possible that that missing side is 13. Someone's forgotten to label it. But given the information we've got, we cannot say for sure that third triangle is congruent. So for now, let's put an X on it and say we don't know if that is congruent or not. We can't prove it. And it's all about proof, proving that we know for sure things are congruent. Now let's move on to the last medium question. And we have 11, 15, and 15. Now, looking at the second triangle, we have 30, 30, and 22. So I'll come back to that in a moment. Clearly, that's not going to fit. It's got different measurements. We want 11, 15, 15. And the third one, we have 11, we have 15, and we have another 15. So we can say for sure that those 2 are congruent. The first one and the third one. And the proof, side, side, side. They both have the same 3 sides. Now, what about that middle one? Well, you might have noticed that 30 and 22 are double 15 and 11. What this means is that middle triangle is going to have the same angles because the sides are in the same ratio. So it is the same shape, but it's not congruent because it's not the same size. So actually, that's not congruent, it's similar. Congruent is when the size and the shape are the same. That middle triangle, it's got the same shape, but it's a different size. So same shape, different size, that's called similar, not congruent. So I'll make a note of that. It's similar. And it might be asked in exams if things are similar or congruent. So you need to know that that's a similar triangle. But for this particular question, it's not congruent, so we're not interested in it. Moving on to the hard questions, we now have 4 triangles. So we have even more triangles to compare. But again, it's going to be the same method. Now, try to speed this up a little bit. What I'm going to do this time is I'm going to look at these triangles, and for the first question, I can see that every single one has got a right angle. So rather than kind of 3 comparisons one at a time, I'm going to do 1 comparison for all of them. So they've all got a right angle. Well, if they all have a right angle, it's going to be important to have a look at the hypotenuse. So let's look at that next. So for the first shape, the hypotenuse is 10. For the second one, the hypotenuse is 20. For the third one, the hypotenuse is 13. And for the final one, the hypotenuse is 13. So now we can actually eliminate 2 of these. The first one with 10 and the second one with 20 do not match, so they cannot be congruent. But the third and fourth one have both got 13. They do match, so they could be congruent. Another thing to note is for the first triangle there, that's an impossible triangle. If you have a hypotenuse of 10, hypotenuse means the longest side. So how is that other side being 13? That's bigger than 10, isn't it? So the first triangle isn't even possible. It's been incorrectly labelled. And you might see that in exams, kind of wrong things on purpose, just to test you and test that you know what you're talking about, you know what you're doing. So now looking at my final 2, what joins up the pink line with the green right angle? We have 20 and 20. They're both the same, so they must be congruent. So let's give them a tick. And it's HL. We have a hypotenuse and a length coming off it. Moved on to question 2. Again, the first thing to do is identify the type of triangle that we have. So we have a right angle on every single one. Now the last one, although it's labelled with an arc, it does actually have written on 90 degrees, so we can include that. And sometimes in exams it might be that you've got to work at the angles yourself, and it might be that you have to work at 90 degrees yourself. If it's an unknown angle, they're not going to mark it with the right angle box because it'll be obvious that it's 90 degrees. They might mark it with an arc, but it could be 90. So looking at the right angles, again, let's have a look at the hypotenuses. So we have 20, we don't have one. We have, looks like 13, and then we have 20. So now we can eliminate a few. This is why looking at one thing at a time for every single triangle can save a little bit of time. Because, for example, the second one, because there's nothing labelled for the hypotenuse, I know that's not going to be congruent. I don't even have to even look at the side lengths. I know for certain that I can just not look at the rest of that already. It's not going to work. Also, with the first and the fourth one both having a 20 for the hypotenuse, the third one having 13 means that also is not going to match. So that you have to look at the other side, which is 20. I don't have to highlight it or think about it because I already know it's not going to match up. So now let's have a look at the last side. Joining the right angle and the hypotenuse, we have 13 for the first one and 13 for the fourth one. So they are congruent. So give them both a tick and mark H. They have the same hypotenuse and they have the same side length. Moving on to question 3. Now again, I can see some hypotenuses, and then I have 2 that don't look like hypotenuses. Now, in the first one, it's labelled 90 degrees and it does look like a hypotenuse. So that's fine, I can use that. But the second one, it's labelled 90 degrees, but clearly look at the triangle, it's not a right angle. The right angle seems to be the other side that I'm marking in green again. So I'm not sure about that one. I mean, triangles can be incorrectly drawn to try and throw you off. But now let's have a look at the hypotenuses and see if we can confirm our suspicions that this second triangle is an impossible triangle. So for the hypotenuse, we have 13, we have 3, we have 13 again, and we have 9. So with that second triangle, it's definitely impossible because not only does what appears to be a small angle, an acute angle, is 90 degrees, when there's clearly something that looks like a 90-degree angle already on that triangle, and it adds up to 180, so you can't have 2 90-degree angles. The hypotenuse is 3, and one of the other sides is labelled 9, which is larger than it. The hypotenuse has to be the largest side. And actually thinking about it, the hypotenuse I've labelled for that second one, it's actually opposite the one that looks like the right angle. Now, the one that's labelled 90, the opposite side to that doesn't have a measurement on it at all. So there's all kinds of things wrong with that second triangle. We're not going to use it. And then the final triangle, the fourth one, that's got a hypotenuse of 9. And one of the side lengths is 9. Now the hypotenuse has to be the longest side. There can't be a tie break. You can't have 2 that are 9. Both be hypotenuse. It's not going to work. So the fourth one is also not going to be congruent. So what about the first one and the third one? Do they both have the same length, joining the hypotenuse and the right angle? We have 9 for the first one and 9 for the third one. So yes, it looks like they are congruent. And we have a hypotenuse and we have a length. Moving on to question 4. So again, I can see a couple of right angles. Let's focus on those first. The first 2. For the third one, that could be a hypotenuse. And for the fourth one, again, there's something that looks like a hypotenuse. Looks like the angles match, but we might have to come back and talk about this. Now, the hypotenuse, we have 9, 9, 9, and another 9. So the hypotenuses seem to match. And then joining those up, we have a 4, another 4, and another 4. So it appears that all 4 are going to be congruent and we can say they have the same hypotenuse and they have the same length. But it's not going to be as simple as that. Let's look really, really carefully about these and think really hard about these. The first thing to point out is the last one, it hasn't been labelled a right angle. It looks like one, but it's not been labelled. So we can't prove that that's congruent, even though it looks congruent. And the same thing for the third one. Yes, the angle is labelled, but it's labelled with an arc. It's not labelled with a square that clearly says it's 90 degrees. And unlike the triangles in question 2 and 3, where it's labelled with an arc, but it also said 90, this one doesn't say 90 at all. So again, we can't prove that's actually congruent and it's actually a 90-degree angle. So all we can do here is say that the first two congruent for certain. And again, more than likely, the third and fourth one are congruent, but we can't prove it with the measurements we've been given. Now, looking at the final set, again, I can see some right angles. Now, we have a right angle for the first one and the third one. We don't have any angles labelled for the middle two. Now, you'll notice for all of these, we need 3 pieces of information. We need side, 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 angle, side, angle, side, angle, angle, angle side, or we need hypotenuse length. And while that looks like 2, we also know that it's going to have a right angle. So hypotenuse, length, and a right angle. 3 pieces of information. The middle 2 triangles do not have 3 pieces of information, so we don't know enough to prove that they're congruent to anything. So I'll cross those 2 out. Now let's look at the 2 that are left over. Again, just notice that I'm trying to eliminate triangles quickly, so I spend less time thinking about them and investigating them. Now, for the hypotenuse, we have, looks like that's about 18 and another 18, and then joining those up, for the first one, there's only one clue, it's 12, and for the last one, there's a 12, and I think that's a 13. Now, there's a 12, and we have extra information in that fourth question. That doesn't matter. We've got 3 pieces of information that all match up. So therefore, this first and fourth triangles are congruent. It's HL again. And the extra piece of information, it's irrelevant. It's 13. That just means that the first one must also be a 13 as well. And I guess we could write that in.
Ouch! This is why in some videos I have unexplained scratches.